All right, folks, a very warm welcome. I just landed in Boston. This is my first time in Boston. I took an 8-hour flight from London, and then I've been flying the whole time. I was in Sydney last week, London yesterday, gave a talk yesterday, and today we are having a talk here at DEF Conf. But we'll be talking about platform engineering. We have Justin, who'll also talk about, he's the director of AI projects at Mirantis. He'll give you a lot of insight on how we are implementing AI, how we are implementing, or how you can perhaps implement an AI ops strategy towards platform engineering if you are practicing. So, a little bit about myself. I am a CNCF ambassador. I work as a community manager at Mirantis. Started my journey 5 years ago on chaos engineering. Did 4.5 years of chaos engineering, and then joined Mirantis. And I'm doing a lot of platform engineering now. I run platform engineering meetups. Perhaps I'll allow Justin to introduce himself.
Yeah, hello, I'm Justin. I'm Director of AI projects at Mirantis. I've been working with AI and ML for over a decade, and I've been writing software for 30 years. So, yeah, that's me.
All right, folks. Not a lot of folks in the room, but usually the idea behind an agenda that I create is not have an agenda at all, because we don't know where do we end up, where do we stop our talk, what exactly we talk about. So we'll find out what's the agenda for today. But because there are not a lot of people in the room, how many developers are there eventually in the room? Okay, all of you are developers. That's exciting. I thought a few SREs, a few QA engineers, students perhaps. But if you are a developer, what is expected out of you? I'm not sure. I believe this is not Morse code. This is just a translation of hello in 100 languages. If I translate this for you in today's dynamic world, then it looks something like this. I believe a lot of you are aware of the CNCF landscape. So this is what developers are expected to do more than writing code. They are expected to learn a lot of infra, a lot of tools. They are not just asked to develop what they're developing, but asked to do the QA stuff, testing, resiliency. If you don't have a QA team, they're asked to learn different tooling in the CNCF ecosystem. And that has made life tougher for them. And similarly, this was the expectation around 20, 25 years ago when the concept of cloud came in. The idea was a data center interacting with a public cloud environment or maybe a private cloud environment. But this is the reality we have today. We have APIs under the hood, we have multi cloud environments, edge environments, AWS, Azure, OpenShift, VMs, bare metal. There's, I mean, in distribution at each and every level. And this is what I'm talking about. That's beyond legacy systems. I mean, people are moving beyond legacy systems, but even the microservices architecture in itself has a legacy approach to it. And that's why Kubernetes came in. How many of you here are implementing Kubernetes or deploying Kubernetes in some form? I see a few hands. So the idea of Kubernetes was to orchestrate all of this, become a powerful orchestrator and make things simpler. But in spite of maturing, you see, we are still lagging behind. This is the architecture of today. It's just applications with Kubernetes under the hood, still a lot of APIs, still hard to manage these deployments. And this is the goal we have. We want Kubernetes to be the common control plane. It's Kubernetes, make no mistake, Kubernetes is a powerful scheduler. I have seen Kubernetes being deployed on IBM mainframes. But I mean, the idea is to make Kubernetes that one orchestrator or one layer under the hood. And that is where we believe that platform engineering has simplified a lot of things. And the idea of Kubernetes managing all of this has come into reality. I mean, if you know Rancher or other tools that are out there, they are helping these kind of deployments. Even Kubernetes SIGs have come up with KubeSpray. ClusterAPI a long time ago, I mean 5-6 years ago, became pretty popular. Anyone has deployed an instrumented ClusterAPI in this room? Well, maybe you can try it out later somewhere this week and you'll realize how hard it is to deploy an instrumented ClusterAPI. And that is where platform engineering as a concept came in to standardize this approach. I believe platform engineering is not a new concept. It existed for a long time. We have just masked it, or we have created this new norm niche that platform engineering exists, but it always existed in some form of implementing DevOps or infrastructures. But platform as a product is a new concept. Today, we believe in shipping developer portals. We want to standardize an approach where multiple teams, no matter they are multi-tenant or no, they are using certain standards, certain tools for their software delivery, CI/CD, GitOps. There has to be an approach, and which is very team specific, use case specific, and that is why the idea of shipping platform as a product is. How many of you have used, say, Backstage to develop a developer portal? Quite a few hands I see. So that I believe it became a very popular concept around 4 years, 3 years ago, where the idea of platform as a product came in. But coming back to the idea, is DevOps actually dead? How many people believe DevOps is dead? Okay, nobody believes that, but I did a conference in India and I saw around, it was a room of 100 folks. I saw around 40 hands going up that DevOps is turning dead and we are moving past it. I don't believe that DevOps will ever die. I think the conceptualization will always change. Will come into, micromanagement of different tooling, but DevOps is gonna exist in some way or the other as a niche. But I believe the concept of a DevOps engineer has changed over the years, where it's not just, managing operations or taking care of how you ship what your developers are doing, but it's more towards building platforms or focusing on certain aspects. And this is what I talked about. I mean, developers, they don't want to learn new code. They want to be focused more on coding. You want to ensure that there's, the developer experience grows. Your developer is focusing more on what they are already doing. You're removing the cognitive overload and obviously helping grow productivity overall. So these are the reasons why platform engineering was was looked at, or people believed that this concern needs to be addressed and platform engineering needs to be considered. If I may just ask, how many folks here are actually working with platform engineers or working around platforms? Well, I would want to ask you questions on what made that shift in your organization, or how is that shift going on? Are you implementing the right tools? But these were the main concepts. Production releases were happening regularly. Reliability was a concern. Consistency obviously is key. But there are a lot of issues we have with platform engineering implementation as well. I mean, you want to reach these goals, you want to ensure your platforms are manageable, you have the right observability stack in place, you are able to add your tools, because today the infrastructures are dynamic in nature. But this is what the reality is. We are where we are today. I mean, there's a product idea misfit. People don't have the budget in place. The right tooling is still, I mean, as I said, people are not able to understand the right tooling. There is a lack of automated IDPs, a lot of manual stuff going on. Multi-cluster is missing scale. You're not able to add on different controllers. Say you want to add an ingress controller, you're missing out on how to add it to your ecosystem. There's no actual state management in place, and then there are different people controlling. I feel platform engineering is not democratic in nature. I mean, you have your folks who are basically involved in business decision making. They are involved in your platform engineering, but are you consulting your engineers, your developers, your key stakeholders, your customers? I believe that's not there, and that's where we have not been able to reach the reality or the goal there. And I mean, multi-cluster, multi-cloud is the new norm, as I spoke about. I don't think, I was talking to these folks from a telecom company, and they said that within our team we have multiple companies. Like within one company we have multiple companies, and some folks are deploying their ecosystem in bare metal, or some folks are deploying still deploying VMs, or some folks are moving towards Kubernetes. We are not there yet. So that has exploded exponentially, and I'm not sure when do we reach some sort of standardization here. And these are the challenges. I mean, believe you need to have a single application per cluster, but that's the best practice. Clusters are dynamic in nature. You keep adding or subtracting whatever services or tools you want to. There are multiple infra providers, and that has led to a Kubernetes sprawl. There's a tooling sprawl. There's inconsistency. There's no policy in place. Some teams are using open source, OPA or Kyverno. So there are multiple challenges to multi-cluster platform engineering in itself. And if I have to talk about what are your options, what do you have to resolve this kind of a tool sprawl or challenge? I mean, the first thing is do nothing. Just go on with your DevOps practice. Let your developers suffer. Not really go about the fixing, or maybe think about that kind of a direction where you need platform as a product, or think about open source. I mean, cluster API, as I said, maybe try deploying an instrumented cluster API next week, and perhaps you'll try to find me on LinkedIn and ask me, why did you suggest that? It's so hard. There's a huge learning curve, lot of hardships. And then talk about proprietary solutions. I mean, there's, as I spoke about, there's Rancher, or there's D2IQ by Nutanix, or I believe Red Hat must have something as well. Red Hat is everywhere. So, but then again, I know people who have purchased 200 licenses of a product, but they have not even utilized one. That's how proprietary solutions work. You are sold licenses, but bringing that into your environment becomes tough. So what do we suggest? We are trying to suggest start with open source. For any tooling that I have worked with, all the open source ecosystems I have worked with, I have tried suggesting use a mature open source mentality. And that is where we came up with this solution, which is, I believe, part of the Kubernetes evolution movement. I mean, Kubernetes has evolved, and today we have lightweight clusters, K0s. I mean, you don't need anything in terms of CPU to deploy a Kubernetes cluster. That is where we have moved past, I mean, I'm not trying to suggest OpenShift is old, but I mean, we have moved to K3s, K0s, and then I think the current generation changes a lot. And this is what I believe is how you should manage your distributed infrastructures. You need to have your cluster management in place. You need to be able to manage your different services, which is basically beachhead services, your CNI, CSI, policy, ingress, chaos tool, incident management. You need to have your resource optimization in place. I'm not sure if you've heard of a lot of cloud cost management tooling out there, but I believe cloud cost management or resource optimization is booming like anything. I saw Cast AI. I'm not sure if many of you have heard of Cast AI. I mean, come up in a few years. I think last 3 or 4 years. It's a cloud cost optimization tool. But I saw massive crowds near their booth during KubeCons, and they are actually converting it into pipelines. Just letting you know. And then obviously your monitoring, metrics, logging. I don't believe that you can have your platform without that. And that is where I would like to introduce a tool called Cordant. It's an open source tool. We are not here to sell anything. It's a tool that is built on certain principles. You are able to manage your workloads in the right way. And that is what has brought in the Kubernetes evolution. I feel Cordant is becoming the fabric that orchestrates all major workloads. It's open, API driven. You have your abstraction layer. It can be used anywhere. I'll show that in an IDP case. But you see, this is the architectural view of Cordant. It is using, again, it uses ClusterAPI under the hood. We are trying to make it better. We have also integrated Cosmotron, which basically helps you manage your hosted control planes. And then it is not just the cluster API controller, but you have a Kappa controller, a CapZ controller, a controller for OpenStack, for VMs. So basically the KCM or the Cordon Cluster Manager is helping you provision the lifecycle of your clusters. The State Manager is using Project Sveltos, another open source tool, which helps you with your add-on controller management. And then there's COF, which is using Grafana, Victoria Metrics, OpenCost under the hood, to basically help you manage your FinOps, your observability, and the other aspects of basically visualizing what's happening and ensuring your costs are in place. So this is how a platform looks today. I have taken some tooling here. There's Cilium, there's your cluster layer, there's your observability layer, there's a layer for your tooling, and there this is where Cordant comes in. So basically you're using Cordant to manage all these layers. What Cordant is, it's a super control plane. So basically you are using a Cordant cluster as a mothership cluster, which is helping you manage all your different worker nodes, your different clusters, your different workloads. So that's how we have envisioned this tool, and it's open source. It doesn't have a UI. It's on a CLI format right now, but you can deploy your own UI and use Cordant, deploy Cordant. So I mean, I think this slide was created by marketing, so I'm not diving deep into it. But I mean, this is how the process is. What I explained. It's very hard to deploy an instrumented cluster API. You have to define your cluster YAMLs, keep repeating them, and keep deploying them. But with Cordant, because it follows a templated approach, so that template is a YAML file, but you just need to tweak that template and deploy all your services, anything that you want to deploy. So we are having a talk tomorrow. Maybe I can take you through the catalog and how the template works. But AI ops in platform engineering, I'll perhaps take a couple of more minutes before I hand it over to Justin. But who thought AI ops can be something which is, instrumented, or which is seen in a platform engineering concept, because it's usually, using AI for, implementing reliability goals, for implementing your observability stack. So it's very hard to imagine platform engineering and AI ops together. But I believe AI ops and platform engineering and observability go hand in hand. You cannot have a platform without visualizing what's happening. And that's why, if you want to go towards incident management, you want to create runbooks are basically you hosting, say you are trying to run an incident management case, you are hosting it in a runbook. So you need to ensure, even if your performance matrices, your anomaly detection, you're trying to detect anything that's going wrong in a system, a shift left resiliency, you these aspects go hand in hand. And that is where, we came up with this concept of AI ops, which you can deploy with Cordant. I'll take you through some examples. But why AI ops? You need to understand what's going wrong in your system. You need to see the costs, you need to see the data, you need to see the load balancers, how you're auto scaling if there's something that going wrong. So all of it comes together packaged with Cordant. We are trying to deploy something here. We have not really run something yet, but we have a case which I'm going to take you through. So these are your stakeholders. This is an example of a reliability use case, and your stakeholders are your SREs. And there's SREs who are managing the reliability or the resiliency of your systems, and then there's developers who are basically helping you meet those SLIs, SLAs, and SLOs. So, and as I spoke about, your ops or your leadership is basically managing your VP. Your VP or your decision makers are managing your KPIs, and then there's your infrastructure. So if your systems are in production, your main SLAs are your MTTF, MTTR, MTTI. But if your systems are in your lower environments, pre-staging or deployment, cloud environments, then your main SLOs or SLAs are your reliability score, your incident management score, your resiliency coverage. These are the things that you need to take care of, and this is what you can drive through AI ops. You get the data, you try to understand it, you improve. That is how you are implementing AI ops. So these are some benefits I have spoken about. I'm just covering it pretty fast in the interest of time. I want to give Justin some time. But this is a community take we have before Justin takes over. You integrate COF, which is your Cordant, FinOps and observability stack, to do predictive scaling of workloads. You integrate it to do root cause analysis of your failures. You integrate a Cordant mothership cluster to provide you with natural language interfaces, allow them to gather business data, how many clusters are you running, what's the usage, and then you integrate a Cordant mothership for your events, logging, and detecting to automatically detect and remediate your failures. With this, I'll allow Justin to take over, who will take you through the AI ops reality check and what's happening in today's world.
Awesome. Thanks, Prithvi. I'm going to set this down here. Right. So the AIOps reality check. So we've heard about Cordant's capabilities managing thousands of clusters, and this is important because the scale of this problem is pretty massive. But here's the thing. AIOps has delivered on its promise of visibility, so we can see everything. We have dashboards, we have lens, we can pretty much see everything. CPU spikes at 3 a.m., memory leaks in production, network latency patterns. The problem isn't that we can't see, it's that we're drowning in what we can see. And so a typical platform engineer gets hundreds of alerts daily. If you spend 2 minutes evaluating each alert, that's your entire day gone. And so it's just constantly fighting fires at that point. So, and most of these alerts are probably false positives or low priority issues that self-resolve. So we've created observability systems that actually make us less productive, and that's not sustainable, and it's certainly not scalable. Right. So Cordant can manage thousands of clusters, but here's the thing, we're about to hit an inflection point where we go from thousands of clusters to millions of agents. And so Jensen Huang recently said that NVIDIA is targeting 100 million AI agents for their 50,000 employees. That's 2,000 agents per person. And traditional AI ops on the left gives us observability and anomaly detection. It's reactive, and we see problems, we respond, but what happens when the systems themselves become intelligent actors? When they don't just alert on problems, but autonomously fix them. This is where the architecture shifts dramatically. We need mesh layers for governance and orchestration. We need protocols for agent-to-agent communication. We need to think about intent-based actions, where we define outcomes, not procedures. And this is where platforms like Cordant and agent mesh networks become critical infrastructure. It's not just about managing containers anymore, it's about providing foundation for this new agentic layer. And so let's do a little history lesson here. This isn't a sudden revolution. We're evolving through very distinct stages, and it's important to understand where we are and where we're going. So stage one is where most organizations are today. The AI ops era, we're really good at seeing problems. Our dashboards light up, pager duty fires off. Someone gets woken up at 3 a.m. It's better than flying blind, but it's still fundamentally reactive. And so stage two is beginning right now, and this is where things get interesting. We're seeing agents that can actually research and think about problems. They don't just alert you that disk space is at 90%. They analyze usage patterns, predict when you'll run out, and identify what's consuming space and suggest solutions. Something like, hey, you have 47 gigabytes of old log files that can be safely deleted, and based on current growth, you'll need to provision additional storage within 3 days. So, but stage three is the game changer, and this is where autonomous operations within policy boundaries, the agent doesn't just suggest deleting those log files, it does it because it knows via policy that it can. It doesn't just recommend scaling, it executes it because we have policy that structures the boundaries and domain the agents can operate. This all happens within the guardrails you've defined. The key phrase here is within policy boundaries. We're not talking about Skynet. We're talking about intelligent automation that operates within strict auditable constraints. And so let's talk a little bit about the agent sprawl problem. And so who here remembers 2015? Everyone was spinning up containers everywhere. There was zero orchestration, no governance, just containers running wild. We called it container sprawl. And it was chaos until Kubernetes came along and helped us solve this. And so, well, guess what? History doesn't repeat itself, but it rhymes. And so we're about to see that exact same thing play out again with AI agents. And so look at what's happening right now. Every developer building agents with different frameworks. You've got teams using LangGraph, some experimenting with Crew AI, OpenAI's agent framework, Google Agent Developer Kit. They're using different LLMs, GPTX, Claude, whatever. Llama, Gemini, DeepSeek, different security models, different approaches to tool calling, different everything. So the Model Context Protocol that Anthropic released this past year will help us standardize this to some extent. It'll help us standardize tool calling, but without a clear governance layer at the infrastructure level, it's still just organized chaos. And we need the same evolution we saw with containers, from agent chaos to agent orchestration to agent mesh. And if we don't get ahead of this now, we're going to spend the next 5 years cleaning up the mess. And just like we did with containers. Think about the security implications alone. Each of these agents potentially has access to your systems without proper governance. You have no idea what they're doing, what data they're accessing, or what actions they'll be taking. So here's where Cordant becomes critical infrastructure. It already gives us the orchestration fabric for containers and VMs. Now we can extend it with agent-specific capabilities, MCP gateways for standardized tool calling, A2A protocols for agent collaboration, and most importantly, policy enforcement. So let's think about it for a minute. What we need here, MCP gateways are great for standardizing tool calling. So regardless of which agent framework you're using, they'll all interface with your systems with the same way. A2A protocols do something similar. That's agent-to-agent protocol communication. Because these agents aren't working in isolation, they need to coordinate. And so most importantly, and I cannot stress this enough, policy enforcement. Every agent needs to be governed, audited, and controlled. Think of it like Istio for AI agents. Istio gave us zero trust networking for microservices. We need the same thing for agent to tool and agent to agent communication. And here's the killer feature that Cordant helps us bring, which is we can already use COF, which is the observability framework, to track not just traditional metrics, but agent decision trees, tool usage patterns, and this is crucial for actual business outcomes. So without coordination, you get chaos. With the agent mesh built on Cordant, agents register their intended actions. The coordinator resolves conflicts based on policy, and everything is audited. This is exactly the same problem Kubernetes solved for containers, resource scheduling and conflict resolution, but now for AI agents. So what does the agent mesh actually give us? Well, it gives us RBAC. Just like Kubernetes, we define who can do what. And this agent can access production data. That agent can only read logs. Every permission explicitly defined and enforced all the way through. We also get multi-tenancy. Every single action gets logged. When an agent makes a decision, it calls a tool or communicates with another agent. It's all recorded. And we have zero trust networking, which is incredibly important for agent communication. No agent is trusted by default. So each request needs valid credentials and explicit permissions. We also get circuit breakers and rate limiting and observability. So, and on this slide, I just wanted to highlight a few other projects that we have here. We have OPA, the Open Policy Agent, which it revolutionized policy as code. Instead of hard coding authorization logic, you define policies. And just to mention, this is not a greenfield situation. We can borrow these ideas from existing projects, like the cloud native ecosystem. Istio showed us how to manage service-to-service communication at scale. We're doing the same thing here. We'll take questions after we're in the hall here. And so at the end of the day, these agentic processes are all about ROI. And are there agents you're deploying actually reducing costs and increasing productivity? Are we measuring their effectiveness? Are we iterating and improving? Thank you. And so the McKinsey research on advanced industries found that agentic AI could drive 30 to 50% cost reductions through automation and streamlined operation. They're projecting 450 to 650 billion in additional annual revenue potential by 2030. And but on the flip side of that, the Gartner survey basically stated that over 40% of the current agentic AI projects will be canceled by 2027. And so why? Escalating costs, unclear business value, and inadequate risk controls. So this is the critical point. The technology works, but only when it's properly governed and measured, and organizations that rush to deploy agents without the proper orchestration, without measured frameworks, without clear success metrics, they're the ones that will fail. And So the question really comes down to, are you measuring the effectiveness? Are you iterating based on actual outcomes? Are you building benchmarks that survive model updates? And because the models change, GPT-6 is coming. Claude's next version will be better. Open source models are catching up. Your agent infrastructure needs to be model agnostic and future proof. And so here's my challenge. Don't build for the models we have for today. Build for the capabilities we'll have tomorrow. And Cursor is a good example of this. They succeeded because they built their platform when tool calling wasn't good at all. But they built on the fact that tool calling within these models would eventually get much better. And so they ultimately won because of that. So the organizations that win won't be the ones that with the most agents. They'll be the ones that with the most disciplined approach to agent governance, measurement, and continuous improvement. And so some links for you guys. You can find Cordant on GitHub here. And using Cordant with AIOps approach here. Yeah.
So if I go to the previous slide, we created a document with how you can deploy Cordant with an AIOps approach. There's an idea of deploying it using K8s GPT. There's an idea of deploying it for the FinOps aspect of it, just chaos engineering. So there are some approaches or there are some ideations that we are compiling as I spoke of, and that's why this is the document. You can scan the QR and find the document. So because we couldn't cover all of it in one talk, I believe. I mean, 15 minutes is a lot for a talk, but 35 minutes sometimes becomes less. So yeah, and if you're on the CNCF Slack, choose to join the community. In tomorrow's talk, we'll talk more of the provisioning side of things, how we are trying to drive an AI ML aspect to platform engineering. So that's all, yeah, and we'll see you tomorrow at 9 a.m. And thank you so much for joining in. I think we have a minute.
We have three minutes for questions.
2 minutes or 3 minutes for questions. So yeah, if you have any.
Yeah, you said circuit breaking patterns. I'm not familiar with this term. Is that like a cost limiting?
No, not cost limiting. Circuit breaking being if an agent essentially fails. You don't want it to just run continuously in a loop, continuing to try. You need to cut it off and basically either heal or bring, alert up the chain, basically.
Okay.
Have any other questions?
So you were talking about Cordant. I want to know if Cordant is dealing with the self-healing pipeline. It's like it heals itself and then, so it deploys. I got it until then. Does it also self-heals? Because...
No, it doesn't self-heal.
But then it gives you metrics, how things are going bad.
It doesn't give you metrics. Again, it is integrated as another worker node. So the metrics side, say your cluster manager is your management cluster. The metrics again become a worker node. So that is what is helping you get metrics. So again, the worker node, it's a Cordant deployment, but it is using say Grafana or Prometheus under the hood. So it's a different deployment. It is not the management cluster that is being deployed.
One last question.
Can you say where your document is if we don't have a phone?
Sorry,
Oh, the document.
yeah.
You had the QR code. Is it also on the web?
It's not on the web. It's not on the web.
Oh.
It's a work in progress. So you can take a picture, and it's a document that we are working on. It's in my Google Docs. But yeah, hopefully it will be on the web in the next month, a couple of months. We'll see. We want to do a working paper behind it, but it's a work in progress.
The recording will also be online in 1 to 3 days. Right now it's live, so you could check it on the YouTube DevConf US page then.
All right. Thank you so much, folks.
Yeah, thank you.
Appreciate your attendance.